Okay. Okay, so we have 40 to 50 seconds. I will mention that we have at the registration desk a number of lost items that have at one time included a phone, a watch, and a number of other things. So if you are missing something or you know somebody who says, oh my God, where are my keys? Check the registration desk. We might have them. Yes. Check. I don't know the full list, but I know that it was long enough that I stopped trying to remember it. All right. Welcome to our next talk. This is Chris Paget, who is an independent hacker, and he's going to tell us how to clone cards for less than $250.
Thank you. Can everyone hear me? Is this on? Can you hear me? Okay. So, a couple things real quick before I get started. First off, hack the con. I decided that the Shmoocon CFP was a form of input, and as such, it needed to be fuzzed. So instead of writing a talk and submitting it for a track, I submitted one talk to all 4 tracks. So my talk is split into 4 little sections, each one of which is designed to fit neatly into one of the Shmoocon tracks. Something somewhere must have overflowed because John Callis has put me on stage, so guess it worked. Press coverage. You may have seen my video on YouTube and some of the coverage in the press. If you have, stick around because there's a whole lot more content here than has been online. And finally, beer. If you still have questions when I'm done, find me in a bar and buy me a beer. I'll keep answering questions as long as you keep buying me Yingling. Okay, so break it. I want to start off by talking about what the program is that I've actually broken here. It's the Western Hemisphere Travel Initiative. It incorporates a number of different programs. This being one of the most prominent ones. This is the passport card. This one actually belongs to my boss. It's the Western Hemisphere Travel Initiative incorporates the passport card, the enhanced driver's license that's being issued in New York and Washington states. It's going to be deployed in all other states at some point. There's also a few other programs, Nexus, Fast, Sentry. They all use the same technology. They all have the same kind of tags. They're all interoperable. So this equipment will work for all 5 of these programs and the superset WHTI as it's going to be implemented in Canada and Mexico as well. It's only good for land and sea entry. It won't get you in on an airplane. If you're coming across the border from Canada or Mexico or the Caribbean by foot or by car or by boat, this will get you back into the country, as will your EDL or your various other cards. It includes an RFID tag. Ostensibly to speed the entry process. I'm actually going to shoot that argument down a little bit later, but we'll come back to that. So, as I mentioned, these things have RFID tags in them. The technology that's used is EPC Class 1 Generation 2. EPC is an electronic product code. Compare UPC, which is a universal product code, and straight away you can guess that these things aren't much more than a barcode. And they aren't. They have a 96-bit ID number. They operate in the 900 megahertz ISM band, which leads to some pretty interesting consequences, as we'll see later. Hence the woohoo, we like the ISM band. By design, this thing has a 30-foot read range. Don't mistake this with any other RFID technologies that have centimeter read ranges. This thing's designed to be read at 30 feet. With my equipment here, I can read them at about 20 feet. And I'll get into how I can bump up that range and what kind of ranges you can get out of this. There is no encryption whatsoever. There is no authentication. There is no security. There is nothing. These cards are wide open. In terms of authentication, there's a couple of things that could be loosely classed as authentication but don't really work as such. And in some parts of the system, like the reader, there's just no authentication at all. I'll come back to that. The reason why you can get these great read ranges out of this is because it's not a magnetic coupling like RFID. You don't have a coil in the reader and a coil in the card that inductively couple together. The system is a much closer approximation to radar. So if you think of this as a radar tower, and you think of this as a plane, what this is doing electronically is the plane kind of moving its wings back and forth to change its radar cross-section. This is doing that electronically. It's electronically changing its coefficient of reflectivity to alter how much radiation gets reflected back to the reader. It's a true radio broadcast. It's not an inductive coupling, which is why we can start applying radio techniques to it, because we're not limited to just an H field. In terms of authentication, yes, it's a barcode. It has a couple of secret codes. There's a lock code and a kill code. If you set the lock code, then you have to unlock the card in order to change the ID number on the card. That's all it does. The kill code kind of makes the tag self-destruct. It makes it blow itself up and just cease operating. Once you've set these, you need to resend them again in order to take whatever action it is. And because there's no channel security, the codes end up being broadcast with 1 watt of CW modulation at 900 megahertz. Now, to put this in perspective, 1 watt of CW, any ham radio operator will tell you that CW is by far the most reliable form of communication. If you can hear the carrier, you can receive the signal. It's as simple as that. The Mars Global Surveyor, the satellite that's orbiting Mars taking pictures, that has a beacon on it, and NASA recently injected an audio signal into that beacon and invited ham radio operators to try and receive it. The beacon on MGS works at half the frequency of this, so roughly the same band. It's still UHF. It puts out 30% more power than this from orbit around Mars, and ham radio operators can listen to it in their backyards. So you can sniff the codes on these things as they're transmitted from the reader to the card from Mars. Nice and secure. Alternatively, if, like me, you're not a US citizen and you don't really want to be messing with the federal government on your way back into the country, there are other attacks to recover these kill and lock codes. You can do differential power analysis against these things. So the idea is, as you send each bit of the code, you monitor how much power is being reflected back from the card. If the card is still checking bits, if it's still validating that the code is correct, it will still be consuming power, and you'll see that reduced amount of power reflected back. The moment that you stop seeing that power reflected back and you see the reflected power going up, then you know that the card is consuming less power, which means it stopped validating bits and you've got a bit wrong. So you can pretty trivially, with the right equipment, and I'll get back to that, you can do differential power analysis against these things to just recover the codes in absence of anyone else that actually knows them. On the readers, so this little toy here, this is an XR400 RFID reader, originally made by Symbol. Symbol's now been bought by Motorola. This is enterprise-grade hardware. So this is designed to be a black box component in a much larger integration. Unfortunately, it doesn't actually even understand the concept of authentication. It has a nice web interface that asks you to type in the word admin twice. But that's the sophisticated portion of it, actually. It listens on TCP port 3000 for the actual RFID interface. And the API doesn't even understand the concept of a password. If you can get a SYNAC from port 3000, that's it. You can control the reader. You can query tags, you can reprogram tags. So I started scanning the internet, looking for port 3000, found quite a few of these things just online, on the internet, just open for querying. And then my ISP got a complaint from someone who'd received 3 of my SYN packets over the course of 8 hours and decided that they were going to cut me off if I continued. So I don't know what's up with that. Anyway, as I said, it's enterprise-grade hardware, so it's designed to be a black box component in a much larger integration, which means it's not that great for low-level hacking. It does have some capabilities, but it's not fabulous. So if we put these dots together here, we've got a passport card with an EPC Gen 2 RFID tag. EPC Gen 2 RFID tags have no security, and they can be read at 30 feet. So in theory, we should be able to copy passports from 30 feet away. Really? Yeah, really. This was my setup when I loaded up Dan Goodin from the register. You can see this is my car. This patch antenna, this thing. Well, you see, if you hide it behind the tinted window in the rear of your car, nobody can see it. So yeah, we drove around San Francisco for an hour, copied about half a dozen of these things, just driving around Fisherman's Wharf. It really is that dumb. Okay, build it. How do we put this stuff together? This whole project started because of the ACLU. They helped me out with my incident with a certain RFID vendor at Black Hat, who doesn't like being singled out, so I'll just say that their doors are highly insecure. I'm glad someone got that. They approached me and said, Chris, we've got some interest in this passport card system and the EDLs, and we have some concerns. We're pretty certain that the technology's broken, but nobody's yet actually done it. If we pay for your equipment, do you want to build it? Do you want to break it? Yeah, why not? Why wouldn't I? So I started pricing up this stuff, and this reader alone is $3,000 retail. There's no way that's low budget, so there's got to be a better way to do it. eBay to the rescue. eBay is fabulous. You can buy anything on eBay. Total cost of the antenna, the reader, and the cables, $195 plus shipping. Same part numbers? Say again? Same parts. This is all official Motorola parts. It's retail hardware. As anyone who knows, as anyone who uses eBay should know, but unfortunately not enough do, if something seems too good to be true, there's a very good chance that it is. I thought about this for a minute and thought, well, I'm getting $3,000 of reader for 90 bucks. That's 97% discount from retail. Unsurprisingly, when this thing turned up, it didn't work. Wasn't entirely surprised by that, and so it arrived on a Friday. I figured, well, I'll take the weekend. If I can fix it by Monday, then I'll keep it. If not, I'll ship it back and see if I can get a replacement. So opened it up. First thing I noticed was that it uses BGA chips. BGA is a ball grid array. The basic idea is that you have surface mount pads on your PCB and surface mount pads on your chip. You drop little balls of solder between the two, heat the whole thing up, and then the balls melt and make contact. No pins. That's the advantage of it. The disadvantage of it is, as you can see here, the contact between those balls and the PCB or the chip, one or other is going to break sooner or later, just because as the thing heats up and cools down, you've got two different materials that expand and contract at different rates. So sooner or later, it is going to crack. This is actually a very common failure mode for electronics. If you hands up anyone here who's had an Xbox 360 given the red ring of death. Okay, you've all been victims of a BGA failure. It's extremely common. Simple test: if you've got a piece of equipment that you want to know if it's suffered a BGA failure, just push on the chips and boot it up. If it works perfectly, then you know that you've pushed the chip into the ball, into the board, and you can start looking at it as a BGA repair to get your equipment working again. In my case, I had about 12 fingers pushing down on various components, and the thing booted up perfectly. So I knew I was dealing with a BGA failure. How do you go about fixing this? Well, the idea is you heat the thing up. You get it hot enough that those balls of solder melt again, and then surface tension will draw them up and they'll make contact, and when it cools down, it all sets and it all makes contact. There's a few ways of doing this. One of the most popular ways on the interwebs is the towel trick. I cannot describe how wrong and bad and ugly and no this is. The basic idea of the towel trick is that you take your Xbox, you wrap it in a towel, you disable all the fans, and you wait for the thing to overheat to the point at which it melts. I kid you not. If anyone here has ever done that, I suggest you go look up thermal runaway on Wikipedia and count yourselves lucky. The reason why this is bad is because silicon, as it heats up, its resistance goes down. So its resistance goes down, meaning that the current through it goes up, which means that the heat level goes up, which means the resistance goes down even more, and eventually the whole chip will end up as a tiny molten ball in the bottom of the case. Second option is a toaster oven. You set the toaster oven to above the temperature at which solder melts, stick it in, come back in an hour, and it should have all melted and fixed itself. Toaster ovens just aren't manly enough. I need something to offset the crazy shoes. So instead, I went out and bought a gun. A heat gun, to be precise, but a gun nonetheless. Cheap and nasty, $20 from Lowe's, high, low, off. It doesn't have to be sophisticated. There's a link here to YouTube if you're one of these monkey see, monkey do kind of people. Basic idea is that you take the circuit board out, you cover any plastic components with tin foil so that it acts as a heat shield. You don't want to be melting your connectors and your memory sockets and whatnot. 2 minutes on low heat, both sides. You want to warm that whole PCB up. You don't want to introduce any thermal shock. Once it's warm, you focus high heat on the chips for 2 minutes. Just really blast those things, get them nice and hot. Any overclocker will inherently be scared of temperatures above 60 degrees C on their chips. If they're not plugged in and you're not at risk of thermal runaway, you can get them considerably hotter than that. So heat guns are good. Once you've done that and you've melted all that solder underneath the chips, you've reflowed all of that, 2 more minutes of low heat, topside only, so you don't knock any chips off. Trust me, you don't want to do that. Just so that the thing cools down a little more evenly and you don't get thermal shock as it cools down. In my case, this thing, I did that with this and it worked perfectly first time and I've not had a problem with it since then. So BGA fractures are very, very easy to repair. So now that we've got the hardware up and running, we can start looking at the software side of things. This thing runs Windows CE, 5.1 to be precise. I'm not a fan of CE in the slightest. I'll come back to why. But the tool chain that you use, you'll need is Embedded Visual C++ version 4, just to start out with. This used to be freely downloadable from Microsoft. When I started this project, there was you search for Embedded Visual C on Google, and the first hit was to MSDN with a download link for free. That link seems to have broken, so you may have to go up on MSDN to get hold of it. I don't know what the deal is there. You also need the platform SDK. This is essentially the compiler engine for EVC specifically for this device. So that forms the bridge between the Visual Studio 6 IDE and the actual device itself. It also comes with a thing called the device configuration package. This allows you to build custom firmware images for it. So you can add executables to it, you can tweak the operating system, whatever you like. The API that it comes with supports both native and remote code. So you can develop locally on a laptop that's attached to an Ethernet cable like this, or you can develop code that runs on the device itself. It's pretty good. You can actually develop on one and then rebuild for the other. It's probably the only good thing that there is about Windows CE. The API itself, it's kind of functional, but barely. Their library is beta, and it shows. You can expect lots of random access violations. You can expect lots of random errors. Don't expect your code to run under whine. My code runs perfectly until I try to actually write a tag out, and then it crashes. Works fine under Windows. Who'd have thunk it? The reason why I don't like CE is because when your code crashes, about 50-50, it'll take out Windows CE as well. So it's always fun when you're developing and debugging and you have to wait 3 minutes every time you test your code for the device to reboot. The API is pretty simple to use. RFID open, RFID close, configure TCP/IP. It's pretty self-explanatory. The problem with it is that if you do find that you get into developing for these things, don't trust that the API actually supports any of the functions that are listed. I tried to use all kinds of stuff in the API to do all kinds of clever things. Couldn't figure out why it wasn't working, and then I scrolled down to the very bottom of their documentation, and they said, oh, by the way, we know that we've listed 30 or 40 API functions. We've only actually bothered to implement these 5. So, fun. Okay, so my user interface that I built, quick demo here. So we've got three panes here. On the left-hand side are the tags that are currently within the read zone of the antenna. In the middle, we've got a list of all tags that the reader has seen since the software was started. And then on the right, we'll be able to see more details for each individual tag and then write them back out. So if I take my passport card, wave it over the reader, up it pops. I can then say, take this ID number and copy it back out. Take a completely random RFID tag. And there we go. That's now a passport card. It's that simple. Yeah, these things are really sophisticated. In terms of read speed as well, I've mentioned the range, so I doubt I can actually hold this thing high enough to get it out of the read zone of the antenna. No, it's too far. I can't actually stand it up because the cables pull it over. So yeah, we've definitely got 20 or 30 foot read range easily. And in terms of the read speed, because speed is going to be a factor if we're driving around trying to clone these things, I've got about 30 or 35 tags in this bag. If I wave this over the reader that quick, if I do it a little slower, wow, that was an anticlimax. Okay. So you can see I've got a bunch of tags in here that I've already programmed to look like passport cards. The way that the ID numbers are allocated for these things is very much like an Ethernet card, very much like a MAC address. Each individual organization gets allocated a prefix, and then they can allocate numbers within that prefix sequentially. So you can spot the prefix like I've done here. 3 cards with that prefix, you can be pretty certain that they're passport cards. You don't actually need to see the card in order to copy the tag ID. You could just sequentially number your tags and hope that one of them sooner or later is going to hit. So I can type anything that I like in here. And then I can write that out. Oh. And there we are, dead beef, bad food. You can write any tag you like. So I could quite easily, buy a couple of thousand tags, give them a couple of thousand sequential passport card numbers, and then drop them in someone's trunk as they're about to go through a border. Not that I would do that, really. So, okay, so we've established that we've got pretty good read range, we've established that we've got pretty good read speed, and we've established that it's pretty easy to write the tag IDs out again. So the RFID on this it's pretty broken. Okay, so there's that. The source code for that is going to be up on rfidhackers.com. Probably tomorrow it'll go up. My slides as well. So let's talk a little more about this read range. The limit on the read range is the need for the tag to be placed in a certain field strength in order for it to be able to power itself. This reader puts out 1 watt of RF. This antenna has 6 dBi of gain. Now, when you're talking about antenna gain, you're talking about gain over what's called an isotropic radiator, which radiates completely perfectly equally in every direction. So when you talk about the gain of an antenna, you're talking about focusing that radiation into a specific region. So the reason that this has gain is because there is a 60-degree beam width coming out of the front, and it doesn't really radiate anywhere else. It's just within that beam to the front. So obviously, the narrower the beam, the higher your gain, and the greater your range is going to be. If you increase your transmit power, we're dealing with radio here, not with a magnetic field. So we have an inverse square law with power, not an inverse cube law. So if I increase from 1 watt to 10 watts, 10 times the power, I should get square root of 10, about 3 times the range. If I increase my antenna gain, I can also increase the range. For every 3 dBi that you increase your antenna gain, you double your range. So if I was to go from my 6 dBi antenna here to a 12 dBi Yagi, I should see a factor of 4 increase in range. So if we run the numbers on this, if we hypothetically put 10 watts into 12 dBi and compared to this setup here, we should get 248 feet. Fortunately, someone's actually done this. A company called ThingMagic, they produce a competing line of readers. They put 10 watts into 12 dBi of antenna and got 100% reliable reads at 65 meters, about 213 feet. Personally, I don't care about being 100% reliable. Any read is a good read as far as I'm concerned. So if they got 100% reliable at 213 feet, I would expect to see something at 248 feet, and we appear to be conforming fairly well with theory. So let's amp it up. Let's see what the logical conclusion is for this. We're operating in the 902 to 928 megahertz ISM band. This is industrial, scientific, medical. This is primarily a ham radio band. Ham radio operators are the primary owners of it. And under an exception to those rules, which is the Part 15 FCC rules, if you limit your power levels and you limit your antenna gain, and you limit how often limit how long you stay on the same frequency for, you're allowed to use the band. However, ham radio license, hands up who has a CISSP in this room. Getting your ham radio license is considerably easier. Once you've got your ham license, you have no limits on antenna gain. If you can buy it, beg it, borrow it, steal it, you can use it. There's no limit on effective radiated power like there is in the 2.4 gigahertz band. In the 2.4 band, if you use a high enough gain antenna, then the field strength within that beam, you can actually exceed the legal limit. No such problem with the ISM band at 900 megahertz. In practice, 18 dBi is going to be about the best antenna that you can buy off the shelf. If you want to start getting into building your own arrays of helical antennae, you can get to 20, 25 dBi relatively easily. You also have a power limit of 1.5 kilowatts. Little bit of radiation. So let's run the numbers here. We've got 1,500 times as much power, so 39 times the range from the power increase. 12 dBi of increase on the antenna, so another 16 times factor of range. And in theory, we should be able to read these things at 2.5 miles. Second? True, okay. 1,500 watts is a huge amount of power. That's terrifying power levels at 900 megahertz. That's instant sterility. Likewise, 18 dBi is kind of a lot of antenna. That's pretty much pushing the limit of what you can buy off the shelf. So let's scale back a little and figure out what we could reasonably achieve as a suitably motivated group of hackers. So again, we start off with our 1 watt into 6 dBi. 300 watts is much more reasonable. That's much more obtainable. 15 dBi of antenna gain, again, much more reasonable. So we get a factor of 17 from the power increase, we get a factor of 8 from the antenna, and in theory, we should be able to read at 0.5 mile. That's still kind of a long way. 300 watts into 15 dBi is achievable. That, as I said, suitably motivated group of hackers could put that together relatively easily. Whether or not it'll do a 0.5 mile is another question, but at least we've got some numbers that seem to support that theory at the moment. Incidentally, if anyone is a ham radio operator and can prove to me why this won't work, I'd love to talk to you. Scale back again and look at what we can do really easily. Well, 902 to 928 megahertz. In the US, it's an ISM band. In Europe, it's a GSM band. So if we look at the GSM 900 frequencies that are used in Europe, the uplink and downlink frequencies nicely bisect that ISM band. So we can use off-the-shelf GSM equipment to amplify our signals, to use as antennas, to talk to these tags. It'll all work because it's in the right band. The reality of it is that GSM 900, your cell phone is actually limited to about 1/4 of a watt. So this thing's putting out 4 times as much power as your cell phone. If you were to just use something like a GSM 900 repeater, You probably wouldn't get an overall power gain out of it because this is already putting out more power than GSM, but you could use it as a relay station, you could use it as a preamplifier. There's lots of things that you could do with it. You could use it as a front end for some other transmitter. You could also use a GSM 900 handset. The GSM specification is infinitely more complicated than the EPC Gen 2 specification. So the baseband processor in your cell phone can already do GSM with relatively little modification and reprogramming. It would be able to talk EPC Gen 2. Adi Shamir pointed this out, actually. And for those who don't know, Adi Shamir is the S in RSA. He pointed out that not only are these things capable of talking EPC Gen 2, but nobody is allowed to even find out if they do, because if you touch the baseband processor in your phone, you're in violation of FCC rules. So black helicopter theories abound in terms of what these things are actually doing and what's been implemented. So let's take a reality check for a minute. All of these ranges are coming from a thing called the radar range equation. Reality is a lot more complicated than this. You can look up the RRE on Wikipedia if you're curious. Reality is a lot more complicated because you have atmospheric loss, you have different signal paths, you have other signals coming in that are causing interference and masking the signal from your card. It gets complicated, and you're not going to get the theoretical limits on range. Also, UHF amplifiers are very expensive. At 900 megahertz, every single component, every circuit trace, every bend in your copper wants to radiate energy. It wants to transmit. So you have to design your circuit very, very carefully. You have to have specific widths of traces. You have to have thicknesses of copper that are tightly controlled. It's very difficult to design, and it's very expensive. 300 watts is quite a lot of power at UHF. Considering you can talk to Mars on 1.3 watts, 300 watts is kind of pushing it. Fortunately, though, antennas are cheap. A 15 dBi Yagi will set you back 40 bucks. It's really easy to get hold of really good antennas and then get some really good range gains out of that, 10 to 15 times range easily. With this, I have a friend who is a ham radio operator, and I took this up to his place, and we hooked in a couple Yagis and tried it. For some reason, the reader said, "Whoa, that's not an official antenna. I'm turning off. I'm not sending my data through that." Not sure how. Could be as simple as a common ground. Could be something more complicated. Once my talk here is over and I'm a little more tolerant towards destroying this stuff, I'm going to dismantle the antenna and figure it out. Either way, 213 feet is the current record. That can be beaten. If I can put together a suitable group of individuals with a suitable pile of equipment, I'm seriously considering attempting a world record on that at DEF CON. Okay, bring it on. Let's look at kind of the people side of this and the government side of this, because it's a fairly major government system that we're talking about here. Why does all of this discussion of range matter? Well, you can read these things at 200 feet, and it is a unique identifier, and it's in your pocket. There is currently no federal anti-skimming law, so there is nothing at all to prevent me from driving around DC with this in my car and harvesting passport cards and EDLs. Nothing to stop me setting up a reader station on the street and harvesting cards as people walk past. It's completely legal. There is nothing illegal about it, unless you're in California or Washington, where they do have anti-skimming laws. Unfortunately, if you're in Washington and you want to start messing with this stuff, the Washington anti-skimming law does not have an exception for security researchers, so you're pretty screwed. One of the main arguments against this being a threat is because it's just a number. It's not just a number any more than your social security number is just a number, or your credit card number is just a number. The data type is completely irrelevant. It's what you do with that data that counts. And in this case, it is a unique identifier for a person. So as I'm driving around, I can point a digital camera out the window of my car. Every time I see a tag, take a picture. If I see the same tag twice, compare the pictures. The person that's in both pictures owns the card. Very simple. I could have set my reader up on one side of the door as you walked in and had another reader, maybe a 13.56 megahertz reader looking for credit cards, set that up on the other side of the door, so that as you walk through, I scan your passport card and get an identifier that I can read at 200 feet and correlate that with the identity that I retrieve from your credit cards. It's very, very easy to tie this tag number back to you as a person. You can tie it to anything that forms an identity. Whatever you have access to, whatever data it is, you can tie it all back and you can build a database of this stuff. It's what it's designed to do. So let's look at some scary scenarios for this. When we reach the point at which all driver's licenses and all passport cards have this RFID technology in it, because that is the way that the US is going, EDL is coming, you can do things like, if you deployed this reader technology in a shopping mall, you could track every individual in that shopping mall in real time. Where are they going? Where are they pausing? Who are they meeting up with? What windows do they look in on their way to which stores? You can correlate the actual credit card receipts from the stores against the ID numbers, just to make sure that you've got your identities right. And then the bad guys can take all of that information and sell it, well, on eBay, probably not, but sell it somewhere. You can expect that to happen real soon now. When there's 300 million of these in circulation, that will become a valid target for bad guys. The one that really scares me is that if you think about how the terrorists will use this, if every American is carrying around a long-range RFID tag in their pocket, your terrorists can now spot a group of Americans from beyond the radius of their explosive. Pretty scary thought. So why is it there? Why do we have identity cards with RFID in them? Well, according to the DHS fact sheet on the Western Hemisphere Travel Initiative choice of RFID technology, line 3, front and center, enhancing the security of our citizens and travelers. This is me calling bullshit. I fail to see how anything that can be copied this easily from this range can ever add any form of security. That is a completely bogus argument. It does not hold water. So why is it there? Well, second reason that DHS like to give is that it facilitates cross-border travel. It speeds things up when you go through the border. Raytheon tested this technology. They set up hundreds and hundreds of different scenarios, hundreds of different tests, and they achieved, at best, 13% successful reads. This is from inside a moving vehicle, so that was largely the problem. The car is big and metal and curved, all of which are very bad if you're trying to pick up a radar cross-section from a very small tag like this. The worst that they did was that 24 out of 25 tags failed to read. So doesn't really hold water as a way of speeding things up through the border crossing. Admittedly, that was the Generation 1 technology, not the Generation 2 technology that's in this. The major difference between Gen 1 and Gen 2 is that the tags are rewritable. Gen 1 tags are read-only. They did slightly increase the read range, not significantly. If Raytheon were to redo this testing with this Generation 2 technology, I'd expect to see results pretty similar to this. Another argument against this is that this thing is still a passport. It may only be good in North America, it may only be good for land travel, but it will still get you back into the country. This is proof of citizenship, which is why this one belongs to my boss, not me. He trusts me far too much. Because it's a passport, there still has to be security involved somewhere. You have to authenticate that the person is who they claim to be. So in this case, it's the card itself that provides the security. It's the holograms, and it's the watermarks, and it's the fancy printing on it, and all that stuff, which has to be verified by a Customs and Border Protection agent who looks at the card, which means that everybody now has to give their cards to a Customs and Border Patrol agent at the border. And how has RFID sped this process up? The stated mode of operation for this stuff is that as you approach the border, your RFID tag will be read, it'll pull up your identity on their screen, and then the CBP officer just has to look at his screen, look at the person in the car, make sure that they look reasonably similar. The problem with that is that I can drive around downtown San Francisco harvesting these things. If I copy 50 of them, 100 of them, 1,000 of them, sooner or later, I'm going to copy a passport card that belongs to someone who looks reasonably like me. Certainly sufficient to pass a cursory inspection at a border from a CBP agent. It doesn't add anything here. It doesn't do anything. It serves no purpose. So why is it there? Well, here's the theory. It provides extra time to look you up. As you're pulling up to the border and as you're coming into the read zone and as you're about to get checked, it gives CBP a little more time to look you up. Maybe they can query a couple of extra databases, maybe they can do a bit more data mining, figure out everything that they would need to know to decide whether to let you back into the country. Unfortunately, everyone's databases get the same benefit. It's not just CBP that can read these cards, so it's not just DHS that can maintain databases of cardholder information. Everyone can do this, or at least anyone with $250 in an eBay account. So what do we do with it? Scrap it. Blame Bush, scrap it. Just accept that the RFID does nothing. It's a useless technology in this application. It should just be thrown in the trash. The entire Western Hemisphere Travel Initiative needs to go down the toilet. No two ways about it. If we really absolutely have to definitely have a new federal identity document, there is another program, Real ID. Real ID, it's a mess. Nobody wants to pay for it, least of all Janet Napolitano, the Secretary of Homeland Security. Last month, she was the governor of Arizona, where she signed into law a bill that effectively prohibited Arizona from adopting EDL because nobody wants to pay for it. So Real ID has its own problems. There's still privacy concerns, but it has potential. You could put a contact smart card on there. I'd have no problem with that because I get to choose who gets my information and when. It's entirely plausible that whatever needs are served by the WHTI, you could roll that up into Real ID, and then instead of having two completely separate identity programs, you can have one identity document and actually listen to these privacy concerns about technologies like RFID. It can be fixed, but, well, Real ID can be fixed, I should say. Western Hemisphere Travel Initiative, this stuff just needs to go away. Don't take my word for it, though. Who am I? I'm just a random hacker. I'm not even a US citizen, so why should you believe me? Well, let's play Name That Quote. I'm going to put some quotes up on the screen, and if anyone can guess who said these things, I'll be quite impressed. Who said, "Unique attributes that EPC Gen 2 tags lack, such as the ability to securely manage, store, and provide access to data on the card, perform complex functions such as encryption and mutual authentication, and interact intelligently via RF." In the same document, EPC tags release their identifiers and product codes to any compatible reader. EPC tags are subject to cloning. An eavesdropper merely has to overhear the tag's transmission to intercept data or passwords. Who said that? Any guesses? You're in the right territory. This was the Smart Card Alliance. These people essentially represent the entire smart card industry. Manufacturers, consumers, policymakers, the whole lot. They probably know a thing or two about the security of devices like this. You can go and read their FAQ. Who said, "A potential illicit hacker could very easily read, again from a distance, the unique ID that is contained and easily create a duplicate. All the potential terrorist need do is be sure that the holder of the fake card resembles the holder of the true WHTI card in order to pass a cursory visual inspection." Didn't hear the right answer. American Electronics Association. These guys represent a whole lot more than just the smart card industry. Okay, a couple of really good ones here. RFID appears to offer little benefit when compared to the consequences it brings for privacy and data integrity. Instead, it increases risks to personal privacy and security with no commensurate benefit for performance or national security. For these reasons, we recommend that RFID be disfavored for identifying and tracking human beings. Who said that? You know, I heard them on previous two quotes. I didn't hear it on this quote. That was DHS. Specifically, their Data Privacy and Integrity Advisory Committee. This was the language in their draft report. Once this report was released to the people that actually stood to lose money if this technology wasn't deployed, the language was toned down somewhat. Okay, last one, and this one's great, you'll like this. State and DHS do not appear to have tested this technology for use in a personal ID card. I urge State and DHS to give careful consideration to concerns that it has chosen the wrong technology for its platform. Who said that the EPC Gen 2 is the wrong technology for the WHTI platform? Now, you guys, you're not thinking, no. There's some good guesses coming out, but reality is even more funny. Hillary Clinton, Secretary of State. This was in a letter that she wrote to various Senate committees when she was the senator from New York. She had a number of concerns about WHTI, not least of which was that it's the wrong technology. Interestingly, she now has ultimate responsibility for issuing these things. So if there's anyone here that does work for the State Department, I'd love to have a conversation with you. Okay, so one-track mind, just to finish up real quick. Where's this research heading now? Right now, RFIDhackers.com. A few days ago, I was looking for a domain that I could just throw my slides up on, put some source code up. RFIDhackers.com was available. I could not believe it. That should not have been an available domain. I felt morally obligated to purchase it, host it, and throw up some forums on it. So right now it's up. There's some forums. You can go join in. There's a bunch of links on there to all kinds of different attacks against different RFID systems. Hopefully we can get together a critical mass of people such that we can use it as a reasonable RFID community. This has been phase 1 of my research, demonstrating that the technology is insecure, demonstrating that these things can be trivially cloned. Phase 2 of the research, or teabagging the corpse, as I like to call it. Incidentally, anyone that doesn't understand that phrase, go ask the Hack or Halo guys. I'm not going to explain it to you. Okay, phase 2 revolves around this magic box of tricks. This is the universal software radio peripheral. So what this stuff is doing in hardware, this does in software. You can essentially build a radio system by gluing together modules with Python. It's really very sophisticated. The University of Washington have a working EPC Gen 2 implementation, so the technology can definitely handle it. I'm looking at taking that code and extending it to be a sniffer, a card emulator, might be a little tricky, and performing differential power analysis against the card. I should mention that the only reason I have this hardware is because Matt Ettus is a very, very nice man. Thank you, Ettus Research, for giving me a discount for a good cause. I'm also looking to start increasing power levels. 213 feet is my target to start with. 10 watts should be pretty easy to get hold of. 15 dBi of antenna should be pretty easy to get hold of. That should give me about 400 feet, which is enough to start off with. If you have any UHF equipment, or if you just have a potential source for obtaining it, then please get in touch. Even better, join the forums. Actually, contribute to this community that's building. EMP weaponry. So the idea of it is, this is RFID self-defense. The idea is, some people take hammers to their RFID chips, some people put them in the microwave. That's a little too low-tech for me. I like to do things the hard way. So I started out with one of these. This is a disposable camera. This thing was conceived by the CCC. The idea is that you charge it up. And then I've got one button here that discharges the capacitor in here through the flash gun, or a button, big red button on the bottom that discharges it through a coil. The idea is you put that next to your tag, push the button, and it generates enough electromagnetic noise that it stands a chance of killing the tag. The problem with this is that it's kind of too small. The capacitor in this is about half the size of my pinky finger. So again, we want to start increasing our power levels. That's a much more interesting capacitor. This stores about as much energy as a low-grade jolt from a defibrillator. So when you add the other 5 in, you're starting to get into instant death if you touch the wrong component territory. So I'm in two minds about whether or not that's a good idea. But even so, I'm already thinking about scaling even beyond that into ultracapacitors. To put ultracapacitors into perspective, these have a capacitance of 1,500 microfarads, or 1.5 millifarads. In terms of capacitance, that's quite a lot of power. An ultracapacitor will store 20 farads easily. It's easily 1,000 times as much energy as this. The problems with them is that they are kind of pricey. They're also kind of slow. You can't discharge them as fast as these things, but they do give you enormous gobs of electrical power. So could be fun to be had there. They also work at slightly lower voltages than these things tend to, so it's a little bit awkward there as well. As I mentioned, I'm considering a world record attempt at DEF CON. There's actually 2 world records I'm considering. Firstly, the longest range at which an unpowered tag can be read. So how far away from that reader can I have that tag, not that capacitor? How far away can I have the tag and actually read it? The second part of that is if I'm over here reading this tag with this reader, how far away can I be and eavesdrop on the conversation? Need people, need equipment, have date and location. The Nevada desert is perfect for this. Nice and flat, open, very little RF noise if you point yourself away from Vegas. So if that interests you, sign up on the forums, join in with the attempt. Before I throw it open for questions, I'd just like to point out to any feds in the room, I know that I was just talking about electromagnetic pulse weaponry, and I know that my email address says I've got an atom bomb. It's a joke, people. Seriously, I don't own any weapons of mass destruction. You don't need to invade me. So as I said, RFIDhackers.com. I'm also on Twitter and Facebook. Don't take it personally if you're one of the myriad people that I don't remember from cons and don't friend you back. So questions? Yes.
I presume you can write from a half mile away as well as read?
The write range is somewhat smaller, but the write range I don't really care about because as long as I can get the ID number, I can write it out using my own equipment.
Could you set an entire city to be the same person?
Say again?
Could you set basically an entire city to appear to be the same person?
Yes. Yes. If I can do DPA against these cards and recover the lock code, I can reprogram everyone's passport card to look like Miley Cyrus. It's kind of fun. Yes.
If you wrap the card in tinfoil, does that prevent it?
Yes. Well, yes and no. They actually come with these little protective sleeves, and I have a whole bunch of them to give away if anyone wants them. The sleeve that comes with the passport card does prevent me from reading this. According to the paper that came out from the University of Washington researchers, the sleeve that comes with the Washington State enhanced driver's license does not shield it from a standard reader. Epic fail, I think. Yes, any more questions? Yes. I would guess that it's shared between cards, but without my DPA analysis being completed, I can't confirm that. Yes?
How complex is the multi-code that you're talking about? Is it something that you could brute force?
It's a 32-bit code. So you've seen how fast this thing reads tags. You could quite feasibly brute force it, yes. Yes? Okay, the passport book uses 13.56 megahertz contactless smart card. Completely different frequency band. It is an inductive coupling, so it's very reduced range. It does have cryptographic primitives in there. There's actually a Java virtual machine inside the passport book with a cryptographic coprocessor in it. So you can do lots of strong authentication, strong encryption, all kinds of stuff, and you know, construct it all in Java. This thing's just a 900 megahertz barcode. No. Yes.
What effect does the card's orientation have on its cross-section?
A lot. if the card is kind of face on like this, obviously it's going to give you more signal than if it's edge on like this. Fortunately, most people carry these things in their wallet, which will sit flat against their body and provide an ideal reflector.
Idea how much it drops on edge? Part of the reason Raytheon only has 13% success if someone with flat.
It could well be, yes. If you put it edge on, you get very little signal back. Yes. Yes. If you can recover the lock code, you can program it with any ID number you like. Yeah, you see, you're making the mistake of assuming that there's cryptography involved here. There really isn't. There's no protection for that whatsoever. Yes?
How the hell did this pig get past in the first place?
I'd love to know. I really would.
Negatives in a safe.
Say again?
There was negatives in a safe somewhere.
My guess is that someone somewhere in the Bush administration made a whole lot of money off of ensuring that this got into WHTI. Given the valid concerns about the privacy of it, there's no other reasonable explanation.
Because I'm from Buffalo, the Niagara Frontier, there's numerous entrances to Canada. And this is a nightmare.
Yeah, you'll see a lot of readers and antennas very similar to this along the Canada border. Any more questions? Yes?
Can you just fry it with like a stun gun?
Possibly. I haven't actually tried it. If you have a stun gun, we can try killing some tags. Okay. Yeah, you can show me how to do that. Okay. Well, I think we're pretty much out of time, so I'll end there. As I said, I'm heading to the bar if there's still more questions. Excellent.
Which Paget are you on Facebook?
The one that looks like me.